Okay, so today I'm going to be showing you what the Doomsday Algorithm is. It's a pretty cool concept. Essentially, the point of it is if you're given any day, month, and year, you can do a little bit of quick mental math and determine what the day of the week it is for that. So if that sounds interesting, I would definitely stay tuned. So first off, what are the Doomsdays? So they're essentially a compilation of one day in every 12 months that no matter what year it is, they will always fall on the same day of the week. So for example, today, for instance, is January 18th. And if you add 7 to 18, January 25th will always fall on the same day of the week as January 18th. And so this is just that, but on different months. And so let me write down the Doomsdays. So there's, first off, there's 4-4, or let me write it like a slash, 6-6. So this is April 4th and June 6th. Oops, I put a 4 there, excuse me. 8-8, which will be August 8th. 10-10, which will be October 10th. And lastly, 12-12, which is December 12th. So all of these will lie on the same day of the week. And these are easy to remember because they're essentially just, the even numbers, except for 2, which I'll get to later. Then there's a mnemonic I like to memorize for the rest of these, which is well, it's not really a mnemonic, but it makes it easy to remember, which is working 9 to 5 at 7-11. And so, as you might have guessed from this, 9-5 is 1, and flip that around, so is 5-9. And then, as you also might have guessed, 7-11 is 1. And once again, flip that around, 11-7 is also 1. So now there's just the first 3, and these are probably the less easy ones to memorize, just because it's not that intuitive. But there's Pi Day for March 14th, which should be fine. And then for February, it's the last day of the month, which is the 28th, which I guess could be memorable because it's the only month with 28 days. And then lastly, for January, it's just 1-3. You have to know that. It's January 3rd. And then there's one small exceptions with leap years. So if it's a leap year, you'd expect the whole chart to look a little weird, but if you think about it, really, it'll only be the first 2 months that change because the 29th is in February, so everything after stays the same. But for January, it'll be 1 day ahead, and for February, it'll be 1 day ahead. So it'll be 1-4 and February 29th, leap day. Okay, so now that you know that, how do you apply it? So now all you have to do is know the so-called starting dates of each century. So if you're in the 2000s, it's going to be a Tuesday. And this date will make sense in a second, I promise. Oops, spelled Tuesday wrong. If you're 100 years before, 1900, it's going to be a Wednesday. And if it's 1800, another 100 years before, it'll be a Friday. Oops. And then lastly, if you're 100 years before that, 1700, it'll be a Sunday. And the interesting thing about this is that no matter whether you go up or down, this pattern will just repeat. So if you go to the 2100s, this will be a Sunday. If you go to the 1600s, this will be a Tuesday. So it's essentially just this grouping of dates throughout every 4 centuries. So let me just write cycles here. So how do you use this now? So essentially what they do is they give you a date and a year. They'll then give you a specific date in that year. And so what you want to do is first take the date and compare it. Let me write these as steps. First, take the year. Compare it to its century. So what does that mean? So let's say they give you, for example, 2007. So 2007 is 7 years from 2000. So how does that affect the so-called starting date? So basically, 7 years ahead, there's 2 things you need to do. So for whatever the given number is, whether it be 7, whether it be 29, 36, whatever, you first need to see how much it's displaced by each year, because as each year goes on, the days of the week shift by 1. And then you need to take into consideration leap years. So 7 is quite simple. What you have to do is first you take the number and you divide it by 7. Oh, excuse me. This one isn't dividing. This one's, you take the modulus at 7. And so essentially what this is going to do is it's going to tell you how much it's displaced by every 7 years, because every 7 years it adds a day, and then by the end of the 7 it'll shift. So here this is pretty easy. This is just going to be 0. And then you take that same number 7 and you divide it by 4. And notice this is sort of like this is floor division. So if you've ever coded before, what happens is you just divide it, and then ignoring the remainder, you just take the floor of the integer. So in this case, 7 divided by 4 would be 1 with some following, but you don't care about the following, so you're just going to take the 1. So now what you do is you take these two numbers here and you add them up, and this is the total displacement from the century. So in this case, it's 1 from 2000. So what does this mean? So on 2000, the starting date, or the date in which all of these doomsdays would fall upon, would be Tuesday. But since it's one above that, the falling date in 2007 will be a Wednesday. So that's step 1. Now, step 2, all you have to do is compare it. Oops. Specific date. And by specific date, I mean the month and year. Oh, not year, day, excuse me. To the doomsday of that month. So what do I mean by this? Let's say in 2007, they give you the date October 12th. So actually, this is October 22nd. So you take that date, that'll be 10-22 as an example. Actually, I should know this is an example. Excuse me about my handwriting, it's not very good. So what you do is you take this October 22nd and you take the, it's the 10th month, so you compare it to the doomsday of the 10th month, which is 10-10. So you have 22, and the day of the week that the 10th is on, which is going to be a Wednesday. So all you have to do is some simple math. So all you can do is you can just subtract these. So subtracting these will give you 12. And then you just take that number and you do in modulus of 7 again. And that'll give you 5. So now you know that it's compared to the doomsday, the actual day of the week is shifted 5 up. And so what that's going to do is, since you know this was Wednesday, you just shift 5, which will be Thursday, Friday, Saturday, Sunday, Monday. So now you know that 10-22-2007 lies on, excuse me, I can't seem to edit there due to the drawing app I'm using. So a Monday, and capitalize the Monday. And yeah, that's what you're going to tell. So it seems like a lot of work. If you do a bit of practice, it's very intuitive and it'll make a lot more sense. And it should take maybe 45 seconds to a minute to do all this pretty easily. But yeah, that's the trick. It can work for any date. I'll be sure to post another video giving practice and then go through it myself. But yeah, you can also check. Let me pull it up on my computer. What day does October 22nd, 2007 lie on? And if you look up with me, it'll tell you it's a Monday, because Google has its own algorithm to show. But yeah, that's it. So essentially just take the day, the millennia it's in, or century, I guess, because, take the century, compare it to the century starting date, then see how much it's displaced. Then take the specific date, compare it to the doomsday of that month, and see how much that displaces. And you can just add all the displacements, compare it to the original base date, and that's your date. And then I'll do this in another video as well, but it's a little easier if you essentially just ignore any of these day of the weeks and just convert them all to numbers. Then maybe you have to deal with 3 operations and 4 numbers altogether. But yeah, that's it.